Hey guys, this is Ben Sulsky, Sauce123 for RunOnce.com. As you can see from this slide on the screen, this is going to be Toy Gaming Episode 4. Today, I'm going to try to pack the whole video into around 30 minutes, I hope, hopefully maybe even a little bit less. And we're just going to do one game, but it's an important game, and we're going to move fairly quickly through it. Without further ado, here we go. The game in question is going to be what's called a 0-1 game. That's different from the other games we've looked at because the other games we've looked at so far have had a polarized distribution of some kind or other. So, for example, in Ace, King, Queen, there was either basically the nuts, a bluff catcher, or air without removal effects, and in other polarized games, there was either nuts or air, and there was nothing in the middle. So in this game, everything is in the middle in a certain way. So the distribution is completely continuous, meaning that every player, in the formal version of the game that you can find in Mathematics of Poker, each player is dealt a number between 0 and 1, where 0 is the nuts and 1 is the nut low. And they have infinitely many hands that are going along the distribution. And because there's infinitely many hands in play, they describe the strategies in terms of action regions. So they'll say like, oh yes, we value bet, our best hands until our 80th percentile or something like that. However, I'm just going to number it a little bit differently. I'm just going to say that 1 equals the nuts and 0 equals the nut low, just because I think that's a less confusing way of counting things for most of us. And the other feature of these distributions that's important is they are symmetric, meaning that each player has the same distribution. So, for example, when we looked at the polarized ranges, well, Ace, King, Queen, each player had a symmetric distribution because each had an Ace, King, or Queen. But in the bluff catching games, where one player either had the nuts or air, one player had the bluff catcher, one player had the nuts or air. So those were asymmetric distributions. And I will be representing this sort of 0-1 structure in Cardrunner's EV, similar to my other videos. So the idea is I'm just going to get a board starting at the river so that ranges are so that it's one street and hands are completely static. And what I'll do is I'll just start with an ace, 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 deuce 3 board, where each player has all the unpaired offsuit combos in the river, king, queen offsuit to 6-5 offsuit. So I just, take basically as many hands as I can fit, and just for simplicity, I have them all being, equally numerous. So it's just all the offsuit combos and not using the pairs. And that will give us 2 symmetric continuous distributions, although they won't be completely continuous because, for example, there's only a finite number of combinations that I can represent in Cardrunner's EV. So there will be some discontinuities in the distribution that will make the solutions we find a little bit off the more formal ones found in Mathematics of Poker. And then also there will be removal effects. So, for example, if I'm value betting king, queen offsuit in position in this game, it will make it less likely that my opponent has a king or a queen because it's simulating real poker. And in the 0-1 games, as they're usually represented, there won't be any removal effects like that because there's infinitely many combos. Okay, so moving on. This is the concept of this video. Are bluffs ever plus EV? That's kind of the concept or the question that I want to leave you guys with right now. Because so far in these videos, we've seen a bunch of situations where bluffs are 0 EV, and we've seen some situations where if we bet too big of a sizing, bluffs are negative EV. So, for example, in the Ace, King, Queen game, if we bet too big with our queens, our bluffs would always be negative EV because we'd only get called by aces, and there were just too many aces in the distribution. And in the polarized nuts or air game, at equilibrium, our bluffs were always 0 EV. And off the equilibrium, they could either be plus EV or minus EV. But generally, at equilibrium, they would be 0 EV. So I guess a more precise way to phrase this question would be, under what circumstances are bluffs EV in optimal play? And that's what we're going to investigate with this 0-1 distribution. Although I admit I'm kind of spoiling things because we should be figuring this out as the result of the game and not have it in our heads going in. But whatever. I think this is a better way to learn, if not maybe the purest way to learn. So the first 0-1 game we're going to look at is a half-street game, meaning that for the mathematics of poker guys, half-street just means that the out-of-position player doesn't have the chance to lead out. So we have a forced check from out of position, and we're going to have in position either make a pot-sized bet or check, and out of position cannot check raise. So it's a pretty simple game. There's just two strategic options. That's kind of a tongue twister. For out of position, he checks, and he can either call or fold the pot, and in position can either bet pot or check. So, a few options to balance. And we can think about this game before even solving it, similar to how we did in the previous video, and sort of figure out some things about these continuous distributions, these 0-1 distributions, that are different from the other distributions that we've looked at. So first, in position is going to bet a polarized range. I think that's fairly obvious, because in position is going to want to get called by worse. And to do that, he has to bet some of his bluffs. And if he has a middle strength hand, once out of position folds some of his range, he's not going to be able to get called by worse. And so he'll check those hands and he'll bet a polarized range. A second thing is that before, for example, in the nuts or air game, in position's air was always 0 EV. He could either bet it or he could check it, but he just bet it to get paid off on his value hands. But it's kind of easy to see in this game that all of the hands in position's range are going to be plus EV. And that's just for the reason that, say King Queen's the nuts and 6-5 offsuit is the nut low, and say we have 6-5 offsuit for the nut low. Well, if we check it back in the way these distributions are set up, just some small percentage of the time, we will just chop with our opponent's 6-5 offsuit and win half the pot. Similarly, if we have 7-4 offsuit, then we'll just beat 6-5 offsuit some tiny percentage of the time. Okay, so I think that kind of shows clearly that we have plus EV with every hand in our distribution. Now, if we're at Nash, then we're going to be indifferent between our strategic options. Well, no player is going to be able to unilaterally increase their EV. But to cash that out in sort of the structure of this game without sort of belaboring the point, it means that the EV of checking our strongest check back hand is going to equal to the expectation for betting our strongest check back hand. So, for example, say we had 6-5 offsuit again. We already have established that we have some expectation that's positive for checking back. And if we bet that hand and our expectation is 0, because say that our opponent calls us 1 minus alpha % of the time, as we've been expressing it in these previous games, then we would not be indifferent between our strategic options. In that case, we would just always check, because checking has plus EV and betting would have 0 EV. So I think that sort of thought experiment already shows that these games are going to have a different structure than the games we've already looked at. A similar point can be made for the EV of checking back our weakest value bets and the EV of betting our weakest value bets. This was true in other games, except in the other games we've looked at, all our value bets had the same properties. So we would just figure out what our value betting hands were, bet them, and add bluffs. In this case, we'll have a range of value betting hands. So, for example, the nuts, if we are at equilibrium then, the EV of our weakest value bet will be equal to the EV of checking back our weakest value bet. So, for example, the nuts, a hand like King Queen offsuit, will always have a much higher expectation to value bet than to check, pretty much regardless of the size that we decide to bet, and certainly for a pot size bet. But then we're going to find some combination that's going to be on the weaker end of our value betting region, and it's going to be just a little bit too strong to check back, or maybe just a little bit too weak to bet. And that hand may end up playing a mixed strategy between betting and checking, but more or less that hand is just going to be indifferent between the two options. It's going to get called just enough to have the same expectation as it would if it checked back. And once we have those two indifferences in our range, then we'll know that we're basically at equilibrium for this game type. So I'm going to bring up the card runner's EV file. So before we start, I just want to show the distributions here. So what I did is, well, I'll start with the board texture. As I said before, there's ace, 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 deuce, 3, all rainbow. And we're starting the game at the river, and the pot is going to start at a size of 1. Stacks are arbitrarily large, but we're only betting either 1 or checking. That mirrors the strategic options that I was talking about before. So either have bet 1 or check, and then we either have call or fold. And the distributions are exactly the same, as you can see here on the left. Each player has the exact same range of hands starting the game. And here's that range. For some reason, I didn't include 6-4 offsuit. I don't know why I did that. I clearly could have done that. But here we go. There's all these different offsuit combos. I guess there's, maybe 25, 30 combos. So it's not an ideal 0-1 distribution, but it has, hands that are all equally numerous and that descend in strength. And there are some removal effects because of the kings and things, but those are kind of unavoidable if I'm trying to play around with Cardboard TV in this way. And each player has the same distribution. Okay, so what we're going to do now is I've kind of jumped ahead and solved this for us because I don't particularly want to go through all of the nitty-gritty of figuring out exactly how the distributions work. But having already identified those properties for in position that we want to have if the game's at equilibrium, meaning in position can't unilaterally increase the EV, we can just see if that's the case by looking at the expectation of betting and bluffing with various combinations. So first what I'll do is this region up here is in position's definitely value betting region. And that just is all of his good kings. So it's king, queen offsuit to king, 5 offsuit. And you can see that the expectation of betting all of those is greater than or equal to the pot, which means that they're definitely good value bets. For example, king 5 offsuit, if it bets pot, it wins 0.99 pot. And certainly it's not winning 100% when it checks back. So that definitely means that it's a good value bet. And then we have the cuspy value bet, which is king 4 offsuit. Actually might be a pip lower than that, but that's the region that it's becoming close with. And you can see that it should be roughly close because it has about 84% equity. And for it to be a value bet, of course, it has to be ahead of at least 50% of out of position's calling range. So its EV is 0.93. And then we can go down to the check back tree and see what the EV is to check back, and that's 0.84. There's actually discontinuity here because the king blocker is so important. So actually queen jack offsuit is probably the hand that I should have chosen here for the indifference, but I'm just going to ignore that for now. You can tinker with this if you want to get exactly right. It doesn't particularly matter for the concepts I'm trying to show in this video. And what we can also do is we can see what the expectation is of our weak hands for checking back. So in this case, I've already decided I'm betting the very weakest hands. So these hands are 5, 6, 5, 7, and 7, 4. And then we can see what the expectation is of checking back a little bit stronger, but still very weak hand. So that's 7, 6 offsuit, which is in this distribution the fourth nut low. And what I have here is its expectation for betting, which is 0.07 blinds of the pot, rather. And its expectation for checking, which is also 0.07. So right now, our bluffs are indifferent between betting, and more or less our value bets are about the right sizing here to be indifferent between betting and checking. And then we have some calling region for out of position. And in this case, it's any king and any queen. As you can see, the removal effects skew the expectation for calling with kings over queens. I'm just going to ignore that for simplicity. I could solve this with the removal effects, but it would just take longer and it wouldn't really teach us anything. And then also I added a few other hands like Jack 10 and Jack 9 offsuit in order to get the indifference correct for the bluffs for in position. And just to check this, well, I don't actually need to do that, but the idea being then that, as you can see, the expectation for the bluffing region for in position is positive in this case. And the expectation for the strongest bluff is equal to its expectation for checking. But the expectation for checking weaker bluffs, so I'll just weight these down to 50% right now so we can compare the expectation of checking these weaker combos. Here we go. So for example, the expectation here is roughly the same for betting all of these 6-5 offsuit, 7-4 offsuit. So for example, 6-5 offsuit is 0.08. And checking that hand now is down to 0.007, which makes sense because it only wins when it chops with exactly 6-5 offsuit. So it's a dominating strategy here to bluff with our weakest hands, and failing to bluff with our weakest hands at equilibrium in a game of this structure will just directly cost us EV. So how exactly to conceptualize this is another thing, and I'm just going to go back. And there's some lessons from this distribution. The first lesson is that in position bets two regions, his value betting region and his bluffing region. Roughly speaking, for a pot size bet, and this doesn't actually come up quite in the Card Owner ZB version because these 0-1 distributions don't really lend themselves because of the removal effects, which clearly frustrates me a little bit. But in the case of a pot size bet, actually what in position should be doing is betting his top 20% and bluffing his bottom 10% for a betting frequency of 30%. And the EV of the entire bluffing region is the same. That's just for the reason that, it's going to be exactly the same. But the EV of the strongest showdown value bluff is indifferent between checking back, as we just saw. So in this case, it was 7-6 off, which was the fourth nut low. And it was 0.07 for betting, 0.07 for checking. And out of position calls 1 minus alpha hands that, quote, can beat a bluff. That's sort of a intuitive way of stating the concept that if we're at equilibrium, in position has to be indifferent with his bluffs, and specifically indifferent with the top end of his bluffing region. And the way to sort of plug an equation into that and solve for out of position's calling region is just that once we fix in position's bluffing region, we can just have out of position called 1 minus alpha hands that can beat in position's non-bluffing region. So in this case, because in position was bluffing around the bottom 10% of hands, 90% of out of position's range can beat a bluff. And because it's a pot size bet, he calls about half the time for 1 minus alpha percent. So in this case, out of position calls about 45%. And if we were just playing the pure nuts air game, he would be calling 50%. So you can see that there's a difference in the solution for out of position as well when we add the continuous distribution. And in Card Owner ZB, if we refer back to the simulation again, out of position was calling about 42.3%. I could mess with that a little bit more. It depends on the bluffing regions and stuff. But it's between 42 and 43%, and that's just because of the removal effects. Again, so there's like a 2% gap just because the distribution isn't particularly well captured in Card Owner ZB in this case. Anyway, if in position misses bluff, any of his bluffs, for example, if there's any hands within that 10% to 0th percentile that he just fails to bluff with for whatever reason, maybe he says, oh, I don't want to bluff this time or whatever. In this case, he just directly loses value. So, for example, in the nuts air game we saw before, if we're playing a mixed strategy with our bluffs and we bluff sometimes and give up sometimes, if we just happen to give up this time, we don't really give up any value, unless our opponent is completely clairvoyant and somehow knows that we should have bluffed that time or something like that. But interestingly, in the 0-1 game, anytime we just don't bluff with hands that we should be bluffing with, we just lose like a percentage of the pot. So, for example, if we fail to bluff with the nut low in this game, we lose about 7% of the pot, which is quite a big difference. And then less if we fail to bluff with slightly stronger hands. And so it's a bit different too because the nuts or air games we looked at before, when we're playing exploitively within those games, we either have to bluff every time or never, or maybe we take a more nuanced approach and we say, oh yeah, we're going to bluff with 25% more bluffs than we should at equilibrium. But in this case, it's a little bit different because even if, say, out of position calls too much, it still might be correct for us to bet with our worst bluffs, but just cut some of our bluffs with a little bit more showdown value. So this is kind of a way where exploitive play needs to be right less often, or I don't know, I feel more comfortable at least making exploits when I feel like the game has this structure. Also, I like to look at the expectation of games. So in this case, we looked at a pot of 1 and a pot size bet or check. And the game EV was about 0.55 for in position, meaning that his option to pot bet or check gave him about an extra 5% of the pot over out of position, who had to check and call or fold. And feel free to check out other bet sizes and game EVs. You can play around with this distribution as much as you want in your own Carver's EV and see if a Nash equilibrium for full pot has bigger or smaller EV than half pot, has bigger or smaller EV than 3/4 pot, etc. Okay. So one of the things I get asked about the most when we talk about these toy games are how does this apply to No Limit Hold'em? And rarely do these games apply completely straightforwardly to No Limit, and it takes a little bit of imagination to figure out how to apply them. I guess I find it kind of easy. It's almost like once I solve these toy games, I say, oh, that makes sense, that makes sense. I sort of know how to play No Limit better, but I guess that's easier said than done. So anyway, I'm going to try to explain it a bit. A common situation where these games apply is anytime where we arrive at the river with a continuous and fairly symmetric distribution. That actually won't happen very often, though. The reason is because in a 3-street game, usually what happens is some guy is checking and calling with his range, and some guy's doing the betting. And usually the guy who's doing the betting has a much more polarized range by the time we get to the river. So usually by the time we get to the river, the distributions have some properties, like being, somewhat continuous, because there's a bunch of different bluffs and value bets that get into different ranges. But they're not continuous in the same sort of broad scale way that the 0-1 distribution is. So I think there's limited use for an idea like this at a lot of no limit situations by the river. This is much more true in no limit on the flop, at least in terms of hand values. So for example, we can map each player's hand value, and the flop sort of reshuffles hand values. That's kind of what it does. People flop pairs, people flop gutters, people flop different things. And there's going to be a ton of different hand values that are going to be distributed fairly evenly between both players. But the difference with the flop play is that it's a multi-street game. And there's also tons of draws that are very important. So this sort of static toy game structure doesn't particularly apply. But it's important to see how this game works when we work up to looking at multi-street games and things in future videos. And finally, I think the most important thing to take away from this toy game, in the forums a lot of the time, I see people who maybe have read some posts on game theory stuff or poker game theory and think that it's true that I have to call in order to make his bluffs 0 EV. But this toy game sort of shows that that's an insufficient way to look at situations, at least most situations. Because in this case, which bluffs should get which EVs is kind of the much more pertinent question. So in this case, if I was playing this toy game using the logic of I have to call enough to make his bluff 0 EV, as out of position, I would just go ahead and call 1 minus alpha %, which for a pot size bet would be 50%. And I'd say, aha, I'm playing optimally because he can't bluff for positive EV. But of course, that wouldn't be right, because what he would do is he would just check every single hand in his range, and he would only value bet. And I would just end up calling. So in this case, he would value bet a little bit wider than the optimal strategy says, because I'm calling too much. And he would just never bluff, because all of his bluffs would have positive EV to check. And so I would actually be giving up a lot of EV. So, for example, so what I just did here very quickly is I had out of position call with half of his hands, which would be 1 minus alpha %. And as we saw before, the game value for in position was 0.55 or 55% of the pot. And now I'll just calculate the maximally exploitive strategy for in position. And as you can see, it has no bluffs in it because out of position is calling too much. And he just starts value betting queen 10 offsuit instead of the sort of king 4 / queen jack offsuit we saw from the optimal solution. And never bluffs. And in this case, it increases the game value for him by from 0.55 to 0.57, 57% of the pot, which means that it increases the game value for him by about 40% over what the optimal strategy had, which that's a pretty big difference. So basically, when distributions are continuous, we just have to figure out which expectations we have to give to which combinations, and sort of model the two distributions, and then sort of solve how they interact, which is a much more complicated question than just, I'll just call, X%. You can't just plug in a formula for any distribution and just figure out what the answer is. Okay. So broadly speaking, this concept happens whenever many of the hands in our range have showdown value, but some smaller percent has little showdown value, and our bluffing region has to include some portion of the showdown value region, which is kind of a mouthful, unfortunately. But the idea just being that we get to the river, and we have some hands that are obvious bluffs. Say, like, we have a complete misdraw. But then if we only bluff with those hands, the other player can exploit us by folding an insane amount. Like maybe he folds like 80% of the time or something. And so we realize that we have to add some hands to our bluffing range that have like some showdown value. Maybe that showdown value is like 5%, 10%, or whatever. And there's various thresholds of fold percentage for out of position, and win percentage for checking back for in position, at which we add different hands with different amounts of showdown value. This comes up all the time in poker, and hopefully you'll start seeing these situations. So I have a couple of examples, one from No Limit and one from TLO. The first example here is from No Limit. So we're playing heads up NL, and we raise pre, and we c-bet an ace of spades, seven of spades, deuce of clubs flop, and we get check raised. The turn's the three of clubs, and out of position bets, and we call, and then the river's the queen of hearts. And on the queen of hearts, out of position checks to us. So this is generally a situation where in heads up no limit, people are really heavily weighting their flop, check raise, and turn betting ranges to hands which can river the nuts, which basically means draws. So on 8 of spades, 10 of spades, deuce of clubs, flop. It's basically spade draws, open-enders like 10-9, 9-6, 6-5, and gutters, and some backdoor clubs. So that's generally what people are check raising. And of course, strong flop-made hands that can either continue to be the nuts, or can improve to be the nuts. So, any two pair or better, and sometimes even top pair. So we can suppose that an aggressive out-of-position player in heads up no limit check raises us with like ace of spades, 8x, some spades, some good draws, some gutters, two pair or better, like stuff like that. And on a run out like this, where we get a bunch of draws still being there on the turn, like on the three of clubs, and then on the river we get a complete blank for both players' distributions, like the queen of hearts. It's a situation where it kind of throws the distributions all out of whack of what people were, I guess, quote, planning on the flop. And so what ends up happening is the out-of-position check-raising guy can't bet all of his bluffs from earlier streets, or else he'll just be bluffing way too much. And there's going to be a bunch of different indifferences for in-position, meaning that out-of-position is going to be checking a lot of his bluffs and just folding. Otherwise, he can be exploited by in-position calling him all the time. And so what happens is there's a bunch of hands in in-position's distribution that are objectively speaking really weak, like even Jack High. But the EV of checking back a hand like Jack High can still be greater than the EV of betting it. So I will sort of show that rather than tell it now. And so here we go. I'm just going to start very briefly pre-flop. There's a 87% raising range. I subtracted 3 betting range. I had a calling range. I just had the small blind bet, sort of a value betting region. He gets check raised by a polarized 11.5%. In this case, it's two pair or greater, a bunch of gutters, flush draws, gutters, nut flush draws, pair and flush draw, overcards and backdoor flush draws. And top pair with a spade, as I said before. On the three clubs, I had out of position keep betting with pretty much anything that had anything at all, except he gave up with some of his gutters, just because those combos, he would be betting too much if he bet all of his gutters in this card. He'd be betting, 100% of his flop check raise range, which would be too much, and it would incentivize in position to just shove with like middle pair, which would be a little much. And finally, on the rivered queen of hearts, we can now look at the frequencies for each player. So in this case, out of position is going to have a pretty strong two pair. or better about 23% of the time. And he's going to have a very weak bluff, so a hand 10 high or worse, about 44% of the time. So his ratio of bluffs to value bets is 2-to-1 in favor of bluffs, and he should be bluffing, roughly half as often as he's value betting. So in this case, he can bluff with about a quarter of his very weak hands, meaning that he's checking about 3/4 of his bluffs. So in this case, the small blind in position has kind of an interesting indifference equation to look at with his own bluffs. So we have his own value betting region, which is about 28%, and then we have his very weak bluffs. And then we have some hands that are still kind of bluffs, but have a decent amount of showdown value now that out of position has been giving up with a fair amount of his own bluffs. So for example, looking here now at a hand like Jack High, it's almost a bluff catcher now. It has about 51.5% equity on this card. So we need a ton of folds before that hand becomes a bluff, although it will definitely be a profitable bluff. So as we can see here, the EV for bluffing a hand like Jack 4 of spades here is, or Jack 5 of spades we'll say, is about 26 blinds, but the EV of checking it is about 36 blinds. So in cases where our opponent has to give up with a lot of his bluffs, and those bluffs are distributed between ace high, pairs of twos, and down to like 6 high, a hand that's as strong as Jack High needs to get a ton of folds even before it can be a bluff. And it's going to even be close with a hand like, say, 10 high. In this case, 10-9 has an EV of like 25 for betting. I'm guessing the EV for checking is about equal to that. So this is a situation where definitely all of the hands in the small blinds range are going to have a lot of plus EV, and it's going to be continuous distribution of hands with plus EV even if they're objectively quite weak. And he just has to kind of figure out how many of out of position's one pair hands and ace high hands are still playing and calling, and then decide whether to bluff with some of his medium weak hands that still have some showdown value. So like hands like Jack High, 10 high. And looking at these toy games can sort of say, can show us how to set the indifferences there. So kind of a convoluted example, but these things don't apply super straightforwardly. And the second example is going to be a PLO one. So in this case, the situation is it's a 3-bet pot. Say it's heads up PLO, and the out of position player pots the flop and turn on a king of diamonds, 8 of clubs, 3 of diamonds, 7 of clubs board. So for those of you guys not familiar with PLO, that's a fairly dry flop with a lot of backdoors on it. And then the 7 of clubs brings in a ton of those backdoors. And generally when we're looking at fairly low SPR spots, I'm going to say the SPR here is around 9 or something on the flop. So it's going to be pot, pot, pot in play. In situations like this, the out of position guy is going to just basically be potting a very strong and sort of huge range for protection and value. And often the guy in position is just going to have to get it in with anything that has a decent amount of equity on the turn. And a few hands, though, because there's almost no fold equity for shoving the turn, there's a decent amount of hands that just can never be best now and are equity dogs, or just have enough equity to continue and they need to just call and see the river. And those are generally just hands that are like pretty much all draws with very little made hand component. So, nut flush draw with diamonds, wraps with clubs, things like that. And suppose we know that in position, this should be, this is in position. So we know that in position we'll pot in all his made hands in the turn. The idea being that if in position just has a hand like king 10-9, he'll just shove the turn, just being like, well, my hand's going to be a nightmare to play on the river. And I think that my pair of kings might be good a decent amount because out of position's jamming so much. So I'm only going to call when I have some hand that's worse than top pair. But the river in this case is going to be the 9 of diamonds. And on the 9 of diamonds, obviously most of the wraps completed. The flopped flush draw completed, which both players have a ton of. And of course the clubs didn't complete. But it means that the majority of the flop draw is completed, and because in position is jamming any of his king combos on the turn, it means that his range is very heavily weighted to hands which are drawing, otherwise he'd have to fold. So what happens then on the river here is kind of similar to these distributions that we've been seeing before. In position is going to bluff with some made hands, but probably not enough, and the equilibrium will have out of position folding a lot more than 1 minus alpha % of his hands. In this case then, because out of position is calling with 1 minus alpha hands that can beat a bluff, and in position's bluffing range is going to be so small, what will end up happening is the value betting region and the bluffing region on a river that's this good for in position will contract a little bit from what you might expect. And when the betting region contracts, the calling region will sort of contract for out of position too. So just sort of drew this up a little bit in Omaha Ranger. So here we have the board up here, King 8, 3, 7, 9, and just sort of modeling the distributions here. There's 75% of hands. I'm not going to go through this completely, but there's a wide range for in position. This is going to be in position's range. Then I have a flop calling range. I have his turn calling range, which is basically any strong draw that doesn't have top pair or greater to go with it. And then on the river, there's this sub-river tab, which will tell us the frequency that in position rivers a bunch of different hand classes. So in this case, I'll have a flush, 61%, a straight, 77.5%, two pair or worse, 20%, and a pair or worse, 12.5%. So it's kind of a funny spot where I'm not quite sure, without looking at out of position's distribution, how often he will himself have a flush. But given he potted this turn and then checks the river, he probably won't have the nut flush or the second nut flush that often because he will have already bet those for value. And a lot of his betting range will be, especially after he 3-bet, will just be a lot of hands that make nut and second nut flushes. So my guess is that out of position will have, around 30-35% flushes. So it's a situation that once out of position checks the river, in position just has a ton of equity because so many draws completed and because of what his play looked like on the turn. And so in this case, to play a balanced strategy on the river, he's actually not just going to bet as many hands as maybe he could value bet if out of position was to call him 1 minus alpha %. The reason is just that there'll be some hands, like two pair in this case, that's going to be about 7 and change percentage of his range, that are just going to win a decent amount of showdown. So a hand like two pair is going to win maybe 15-20% showdown. And so for him to bet that hand as a bluff, he really needs out of position to fold a ton. So in this case, because his distribution is continuous, he'll just value bet a little bit more tightly than maybe he could, and he will just go ahead and bluff pairs, probably, and fail to bluff most two-pair hands. This comes up pretty often in PLO situations like this, where you have to look at different thresholds in your distribution where you need different amounts of fold equity to be indifferent between bluffing and checking. All right, and that is all I have for you guys today. Unfortunately, I hope I explained that relatively well. It's easier to show than to tell, I guess. So I would urge people who are watching to go play around with these concepts themselves and whatever software that you find handy. But I think the key concept to take away today are two things. The first is just that in a continuous distribution, or in a unpolarized distribution, where unpolarized just means that there's a lot of different hand classes with different amounts of showdown value, typically the weaker bluffs in the bluffer's range will have positive EV, and the best bluffs that have some showdown value will be indifferent between bluffing and checking back. And secondly, when distributions have this property, the caller's range is generally 1 minus alpha hands that can beat a bluff, as opposed to just 1 minus alpha hands total. And this should complicate your lives in poker and make you guys design your ranges a little bit better. So this has been Sauce123, Ben Sulsky for 101s.com. Good luck at the tables.